Oh, welcome to algebra. Hey, y'all, Mr. Cockburner here. Getting ready to go over some statistics. Today's actually a pretty quick, short lesson. Two-way frequency tables and probabilities. I think a lot of us like the statistics portion of Algebra 1. It's very visual, and we kind of deal with stats every day, just watching football and looking at stats like that and making foul shots and stuff. I don't know. But you can kind of get into everyday life situations with statistics more so than graphing lines or parabolas or something like that with functions. So let's not waste any more time. And away we go. Excuse me. In a class of students, the following data table summarizes how many students passed the test and completed the homework due the day of the test. What is the probability of that student chosen randomly from the class failed the test? So the very first thing we need to do is figure out what? We need to figure out our totals, all right? So what I'm going to do here is make totals down here and over here. So if we look, how many students passed the test? We had 10 who completed their homework and then 3 who did not complete their homework. So obviously if you do your homework, it seems like you're going to pass more than not. Completed their homework and failed was 2. And then did not complete their homework was 7. So there's a total of how many people there? 9 people who failed the test. Now I have 13 and 19, meaning what? We have a total of 22 students who actually took the test. Now how many people completed their homework? That's this 10 plus 2 combo. So that's 12 people. And then we could either go from 3 plus 7 and get 10, or take 22, subtract 12, and get our 10 there. So now that we've completed our totals, right? So we've listed everything about who passed, who failed, who completed the homework, who did not complete the homework. We need to figure out what they're asking us. So it says, what is the probability that a student chosen randomly from the class failed the test? So we have how many people failed the test? Was 9. So 9 out of the total of 22 students, which I think is just shy of 41%, but I think it rounds up. So there's 41% of the people who failed. All right. Like I said, we need to pay attention to our words here. Chosen randomly, so we know that 9 total people failed. So that's going to be the random marker. So there's 13 people that we could obviously pick that passed, but our total is 22. So we need to get these numbers here. I hope that makes sense based off of the information given. In a class of students, the following data table summarizes the gender of students and whether they have an A in the class. What is the probability that a female student does not have an A? So if we just total these up, again, so here we have a total of 16 females. 11 plus 13, there's 14 males. There are a total of 30 people then. There are 6 plus 11, there's 17 A's right now. And then if you don't have an A, that gets you 13. Again, 10 plus 3 is 13. 17 plus 13 gets you your 30. So now what are they asking us? What is the probability that a female student does not have an A? So let's look at our female students. How many female students are there? A total of 16. Does everyone see where I'm getting that number from? My total number of female students. And then we want to figure out what's our numerator. That's going to be does not have an A, so it's going to be in this category here. So that's a 10 out of 16. That simplifies to a 5 out of 8. And that's going to be 62.5% of the females do not have an A in the class. All right? Nothing sexist in this question. That was just the question that Delta Math gave us. So with that being said, We just need to make sure that we know how to get our numerator and our denominator. And again, this is just a question that was chosen at random, and we got our answers that way. In a class of 26 students, 14 play an instrument and 19 play a sport. There are 9 students who play an instrument and also play a sport. What is the probability that a student chosen randomly from the class plays a sport? If you notice, what is not given in this problem? A table. So we have what? A total of 26 students. So we know from this last problem where the total of students is going to go. That's going to go here. But we need to figure out what we have going on the as far as our things that we're comparing. So 14 play an instrument and 19 play a sport. So it looks like we're dealing with instruments and sports. There are 9 students who play an instrument and also play a sport. So we're looking for our combo right there. So what do we have to do is figure out a table. So just to save time, here's our table. And now I'm going to remove those Browns heads just based off of the information here. So in a class of 26 students, where is that going to be? We are going to reveal that to be right there, 26. What other information do we know? We have 14 play an instrument. So where's that going to go? 14 total play an instrument, so that's going to go here. And then we have 19 play a sport. 19 play a sport. So plays a sport, that's going to be a total, right? So that's going to go here. There are 9 students who play an instrument and also play a sport. So where does that go? So plays a sport and an instrument. So that's going to be this Browns helmet here. And now we need to remove those Browns helmet. Again, I didn't really go over setting up the table. So again, plays a sport, plays an instrument, does not play a sport. Obviously, those are the two things that we're comparing. Sports, not sports, plays an instrument, does not play an instrument. So you can see how we're setting up our table. Hopefully, I skipped that step real quick. So where do you want to go? You want to just start with plays a sport? Let's just go with this Browns helmet. When I remove that Browns helmet, what's going to happen? 9 plus what number gets you 19? So we're going to fill that in with what number? 10, right? And then we can figure out what number. We can choose this one. Delete that one. 14 plus what number gets you 26? So this is going to be, going to be 12. And now we can remove this Browns helmet because we don't have anything in that line right now, but we know that information. Let's just go across. 9 plus what number gets you 14? That's going to be 5. I keep doing that. My apologies. Let's go to this Browns helmet. What is that Browns helmet? 10 plus what number gets you 12? Good. That's going to be, oh, Cockburner, you did it again. I'm off my game. It's been a while. 10 plus 2 get you 12. And then we could do subtraction over here. 26 minus what number gets you 26? That's going to be 7. So now what are they asking us? What is the probability that student chosen randomly plays a sport? Sorry. So how many people play sports? We have a total of how many people? We have a total of 26. What's the randomness that we choose? So we have a total of 19 here out of 26 students. All right. Any questions? Again, we're just rearranging data and trying to figure out what question they're asking us. At LaGuardia Airport, for a certain nightly flight, the probability that it will rain is 0.07, and the probability the flight will be delayed is 0.19. The probability of that it will not rain and the flight will leave on time is 0.75. What is the probability that it is raining and the flight is delayed? Round your answer to the nearest hundredth. So again, filling out that table, we have flight delayed, flight on time, so there's those two components. And then we have rain, go away, and no rain. So now what's the information up here that they gave us? They said the probability that it will rain is 0.07. But before we do that, we know our total down here is going to be what? 1, because it's 100%, right? It's either going to take off or not. Everything's going to add up to 1 or 100%, okay? So they said 7% that what happens? That it will rain is 7%, so rain total is going to be right here at 0.07. The probability that the flight will be delayed, just being delayed, is going to be a total of what? 0.19. So now we can move this helmet and this helmet because we can do our subtraction problems here. So if we move this brownie helmet, what's 1 take away 19 or 0.19 gets us a total of 0.81. And then we can remove this Brown's helmet, and say that that's going to be 0.93 because we're going to take 1 and subtract 0.07. And now we need to get these brownies helmets out of the way. What else did they give us? I'm sorry, I was just doing those boxes first. The probability that it will not rain. So not rain is in this column here. So it's one of these two Browns helmets. And it will leave on time. Leaves on time. No rain right there. So we're going to remove this Browns helmet and get 0.75. And now how do we get this Browns helmet? What number, right? This Browns helmet plus 0.75 gets you 81. Let's just subtract 0.75 from 81 and we get 0.06, which now we should be able to get this information. What number plus 0.06 gets you 0.07? That's 0.01, because of these two total of 0.07. And then again, we can subtract 0.75 from 93. Put that in the calculator. What do you get? We're going to remove this Browns helmet. And we're going to get 0.18. Or we could have gone across and got that. All right. What is the probability that it is raining and the flight is delayed? So raining and delayed. So raining and delayed gets us, here's rain, here's delayed. What is this box? 0.01. So that's a 1% chance that it's not going to work out. All right. Again, like I said, this is a quick lesson. I think the hardest part is getting these here and here, maybe getting the table set up. But if you pay attention to what the words are, maybe the hardest part is just reading it. All right. And again, you know what time it is. Lifeline. All right, two-way frequency tables. Again, we're comparing 2 things a day to here, 2 things a day to here, and then going to get a total. All right. So hopefully you like that one. It's quick. It's easy. Maybe quick, not so easy. Watch it again. Let me know. Shoot us an email, and we'd love to help you. All right. Don't forget, thumbs up, subscribe. Here we go, brownies. Here we go.